So we're going to use a mathematical induction to show the Moivre's theorem. Okay, the Moivre's theorem. Okay, so this theorem actually says that cos theta plus e sine theta, uh, everything raised to the power n, is as simple as cos n theta plus e sine n theta. Alright, so we're going to use a mathematical induction to prove this theorem. Alright, so we're going to check for basic cases. For example, for n is equal to 0 and n is equal to 1 if you want, but you can just leave it at n equals to 0. So if n is equal to 0, the left hand side will be equal to, when n is 0, everything raised to the power 0 is 1. Then the right hand side will be cos 0, which is 1, plus sine 0, which is 0. So the right hand side will be equal to 1 as well. Therefore, the basic step has been shown. For example, we can take n equal to 1 as well. Here, when n is equal to 1, what we're going to have is cos theta plus e sine theta is equal to cos theta plus e sine theta, okay, which is the same thing verified. So actually it's much easier actually to get for n is equal to 2, but we're not going to show that basic step. Now the next thing that you do is you're now going to uh, suppose we're going to suppose that it is also true for the nth term, for n, okay, for n greater than 0, of course. Now, so which means that you're going to suppose that the theorem is true. The power n is equal to, we're going to suppose that it is true. This is equal to cos n theta plus e sine n theta. So if you suppose that this is true, your only job is to show that it is also true for n plus 1. Alright, so for n plus 1, this theorem will be cos theta plus e sine theta, everything raised to the power n plus 1. Alright, so this should be equal to cos, where there's n, we're going to put n plus 1 theta plus e sine n plus 1 theta. Alright, so now in order for us to show this one, we're going to work around what we already have. Alright, so what we supposed was cos theta plus e sine theta. So everything raised to the power n. Alright, so for us to have n plus 1, we're supposed to multiply this by cos theta plus e sine theta. Okay, so if we do this, we're going to have n plus 1. So this is on the left hand side. So with the same equation, we're going to do the same on the right hand side. Okay, all right. So on the left hand side, we suppose that cos theta plus e sine theta n plus 1 is equal to this. Then this was supposed to be equal to cos n theta plus e sine n theta. So you can now multiply this by cos theta plus e sine theta, which is the right hand side. So now we can multiply this cos throughout and this sine throughout, but then we group the terms together. So if I multiply cos throughout, I'm going to have cos n theta cos theta plus e sine n theta cos theta. Then if I multiply by I sine theta, I'm going to have plus I cos n theta sine theta. Then this will be minus sine n theta sine theta because of the I multiplied by I. Alright, now here once more, what I'm going to do now is I'm going to group all the terms cos n theta cos theta. I'm going to group all the terms, all the real terms together, n theta sine theta. Okay, so if I group all these terms together, then I'm going to have the imaginary terms together. I'm going to factorize by I. So I'm going to have cos n theta sine theta, then plus this other term will be sine n theta cos theta. All right, we're almost done. All right, now once you reach this point here, you realize that this is equivalent to cos n theta plus theta. This is the first angle, this is the second angle, this is the first angle, this is the second angle. All right, so the minus shows that this was cos, and the cos sine shows that this was cos n theta plus theta. Okay, then plus same applies to this one can be observed to be also cos the first angle n theta plus the second angle sine. All right, now we know that this will also be cos n plus 1 theta. Okay, if you add n theta plus theta, you're going to have n plus 1 theta. Okay, plus e, this is also going to be sine n plus 1 theta. All right, therefore you've shown that cos theta plus e sine theta raised to the power n plus 1 is as good as cos n plus 1 theta plus e sine n plus 1 theta. So this means that it is true for n plus 1. Therefore, the superposition, what we suppose the hypothesis has been proved, has been supported. Therefore, the Moivre's theorem cos theta plus e sine theta, everything raised to the power n, is equal to cos n theta plus I sine theta. So that's how you show using mathematical induction. See you next time.